At this point, you're getting pretty familiar with the concept of triangle congruency. We've discussed side angle side and side 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 in great detail. We've discussed the included angle. We've discussed corresponding parts. We've discussed triangle congruency. And so we're going to introduce you to two additional ways to prove triangle congruency with the angle side angle and angle angle side. And notice that they are the same letters, right? There's an angle, there's two A's, one S, one S. But notice that even though they're the same types of letters and the same amount of letters, the position of the S is in the middle for angle side angle, and it's outside of the two for angle angle side. And so what's happening here is that for ASA, it's the included side. So it's the side that's shared by both angles. Whereas with angle angle side, it happens to be the non-included side. So the nice thing about this is we can pretty much almost prove any triangle congruency as long as I have two angles and a side. It just gets technical with, okay, so we can, but is it ASA or AAS? So we have two triangles, ABC and YXZ. Sorry for that order, but we're going to leave it like that. And if I have two angles, so let's say I have angle A and angle Y, and let's say I have angle B and angle X. Well, in order to use angle side angle, which is what we're looking at right now, notice that I have two angles. So there's the A and there's the A. In order to use ASA, I need to have the side that they both share. That's my S right there in the middle. So we've placed that one in the middle. And it could be any two angles as long as we have the side that's being shared. If that's true, then we can say that the two triangles are congruent to each other. So triangle ABC is congruent to triangle YXZ. That's ASA. For AAS, if I have angle A is congruent to angle Y and B is congruent to angle X, well, if you happen to give me a side that's not in between the two, let's say we give you this side, or even if we give you the other side instead. So if we give you BC is congruent to XZ, that side is not in between these two angles. Then the triangles would be congruent by the AAS. So it's the same idea, except is the side given in between the two angles or not? If it is between the two angles, it's ASA. If it's not between the two angles, then it's AAS. Well, here we go with the usual stuff. So we have two pairs of sides given. We have two angles given. Sorry, one pair of sides given, one pair of angles given. Check this out. These are vertical angles. And vertical angles are congruent. Now the question becomes, okay, I have a pair of angles, and then I have another pair of angles, but did they give me the side that's included? The included side, did they give me the side that's being shared by both of these? Well, in this case, that would be this side and this side. They didn't give me that, and there's no way to prove that. They gave me the side that's not included, that's not in between those two sides. So they did give me a side. They gave me EF is congruent to JH, but it's not the included side. So this is AAS. So yes, it's very much possible to prove this with the AAS. Part B. Well, all we have labeled for us is MP is congruent to NQ. And by the reflexive property, we know that NP is congruent to NP. So far, notice that they gave us two pairs of sides. And think about the four options, right? We have SAS, SSS, ASA, and AAS. But look at what they gave us. They already gave us two pairs of sides. I don't have two S's here. I don't have two S's here. So at this point, my only options are maybe the SAS or the SSS. But is there any way to pick up a third side? Well, we don't know anything else. We don't have vertical angles. We don't have, we did the reflexive property on here. We don't have parallel. We don't have anything else. So at this point, all we have are two pairs of sides, and we can't pull anything else off. So the answer to this one is a no. We can't prove that these two triangles are congruent. Oh, C is quite fascinating. Now, let's take a moment to appreciate that there is a side that's being shared by both of these. So that's a reflexive property. I hope when you're doing the assignments, you're finding the reflexive property, because I swear we've done it like at least 10, 15 times at this point. Okay, so reflexive property, great. We got a pair of sides. Excellent. Notice that these arrows mean parallel. They don't mean that these sides are congruent. It means that the sides are parallel. And if this is a transversal, then by alternate interior angles, angle 4 is congruent to angle 2. And if you flip this upside down and notice that this is parallel, UZ is parallel to WX, then that means that these two are alternate interior angles and that they're congruent. Now, note that we have a pair of sides, we have a pair of angles, we have a pair of angles, so that rules out those two. Those are our two options, but is the side the included side between the two angles? And the answer is yes. And so this is going to be angle, side, angle. I said some important words for part C that you guys didn't write down, so now would be a time to reverse, rewind, replay, and maybe write some of those words down. But in problem 1, part C, write down the words that we used of how the parallel lines helped us, right? I identified those angle pair relationships. You're going to want to put that in your summary. Okay, this might be the beefiest proof we've done so far. And why is this beefy? Well, vegetarians, it's because, look at the given. No congruencies were given. You know, congruency is like AB is congruent to DC. Because if we have 3 congruencies and we're done. We weren't given any congruencies. This is parallel. And then this says midpoint. So we have to find all 3 congruencies ourselves. So let's take this one at a time. If AB is parallel to DC, it doesn't mean that they're congruent. It means that they're parallel. But if BC is a transversal, then that means this and this angle are alternate interior angles. And if they're alternate interior angles, that means that they're congruent. So that means angle B is congruent to angle C, and that's because alternate interior angles are congruent. Okay, and that's nice because that gives me a pair of angles. Great. E is the midpoint of BC. We've established that if there's a midpoint, then it bisects or it divides into 2 congruent parts. So that means this piece is congruent to this piece. I can say that BE is congruent to, oops, we have to first say the given. So the given was that E is a midpoint. So now we can say that if E is a midpoint, that BE is congruent to CE. And that's because midpoints bisect. Sorry about this. Bisect. Okay, midpoint. Midpoints bisect. In other words, it forms 2 congruent parts. And this is a pair of sides. Okay, so at this point we're looking at, we are looking at either the SAS, the ASA, or the AAS. Well, look at this. So we know already that B is congruent to C, angle B, angle C, great. Vertical angles, vertical angles. Vertical angles are congruent. Do you see that right here? Wow. Okay. So that's angle BEA is congruent to BEA to CED. And that happens to be a pair of angles. So remember, we have 4 options: SSS, SAS, ASA, AAS. But look at these combinations of letters, and this might not be the right order. Okay, so don't be fooled like, oh, there's ASA, Mr. Over. Not sure yet until we look at the picture. But if we look at the letters I have two A's and an S. That eliminates that option and that option. And I have to choose now between this one or this one. If we look at our diagram, a lot of you are going to try to do proofs without looking at your diagram. I would strongly suggest with every problem you do for this class for triangle congruencies, please redraw the diagram and label it and work with it. A large part of your success with proofs is to label the diagrams and work with them. So if I look at this diagram that I notice that I have this angle here, and I have the side in between. That's the included side. So I can say by angle side angle that triangle ABE is congruent to triangle DCE. And we're done with that proof. That was a pretty beefy one. You're going to want to stop, replay, repause, rewind, rewatch, retry. I would even suggest try to redo this proof again, but as a paragraph proof. Try to work through the process of it. If you totally understand problem 2 and could do it on your own, then you're going to do great on the test. I thought I would include problem 3 only because we don't usually see reflexive property with angles, but this was a special opportunity for me to show you. And to kind of focus on that, notice that I gave you 2 congruencies already. So it looks beefy diagram wise, but you know it's going to be a pretty smooth proof. All we got to do is find a third piece of the proof. So we've been given 2 things, that angle P is congruent to angle A, and that PN, okay, let's be careful, this is the entire length PN, is congruent to this entire length AE. Now, we need a third piece of information. This is a pair of angles. This is a pair of sides. Okay. I need to either find another pair of sides or another pair of angles. Now, usually if I'm going to pull off a pair of sides, it's a reflexive property because there's a side that's being shared. I don't see that here. There's no like line that says, oh, these two are the same, right? What about angles? Well, we don't see vertical angles and we don't see parallel lines, but take a moment to recognize that for triangle NPL, you have this angle right here. And for triangle AEL, you have this angle right here. And they both have the same angle. So, what I'm proposing to you is that angle L is angle L. Because of a reflexive property. And this time it was a reflexive property for angles. Okay, so I want you to kind of see, oh, it can happen, right? That we could actually be sharing an angle. And it could be reflexive property. Now here is the tricky part. We have angle, we have a side, and we have an angle. Again, this may not be the correct order of things. So I have 2 options. I have either angle, side, angle, or angle, angle, side. The question becomes, I know that this is going to be LPN. It's congruent to triangle LAE. But the question is, what is this going to be? Is it ASA or AAS? Let's look at what we're given. So I have this angle right here, and I have this angle right here. If I'm going to use ASA, it would be the side right here that they both share. But I wasn't given that side, was I? I was given this side. So I was given the non-included side. I was given the non-included side. And so this was AAS. Not bad, not bad. I think maybe it's starting to happen for some of you. I'm getting that feel. So anyway, for your summary, you might need to do this on a separate sheet of paper. This is like a very, 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 very important summary. So don't skip it. You shouldn't skip any summaries. But this one is pivotal because it's summarizing the last 4 videos on these topics. So there are 4 ways that that have been discussed on how to prove triangle congruency. There SAS was the first one, then the SSS, and in this video we talk about ASA and AAS. For each of the 4, describe under what circumstances each would be used. So that means, what do you need to see in a diagram? Or what parts do you need to know to be able to do those kinds of proofs?